Okay. Okay. Now, welcome to today's class. We'll be looking at cycle theory, and it's kind of looking at it in this way. A professor, a medical professor, and not just a medical professor, but a mathematics group is going to take you on this mass and also is going to elaborate it for you in the way you understand. I bet you will not want to change the dial. Just stay tuned. If you will, you will enjoy everything. Welcoming Professor Dr. Izu Okoli, the professor in medicine and in maths. Thank you, sir.
Okay, let's look at circle theory. Good day, class. We will take a series again on circle theory today. I want to start with the basics theorems we have on this particular topic. This is an O-level course, an analysis study, both for those writing WAEC and JAM, specifically for JAM. In your JAM exams, you will find some questions in mathematics that has to do with circles. And they'll be giving you some angles, and then your mind is telling you that you are not with a protractor or thereabout. But these things are just rules. Once you can be able to decode the rule in a particular theory, it's a theory. Once you can be able to decode the theory behind the questions, you can apply them and then get a final answer. So let's look at the basic theorems you have in circle theory. Now, first of all, I want us to look at the first theory, number one. We have a circle like this, then we have this, writing the mathematical illustration. Now, what does this mean? The first theory says that the angle subtend at the circumference, the angle subtend at the equator, at the center of the circle is twice the angle subtend at the circumference. That means that when an angle is formed from the same segment, from the first segment, and then they are bisected, or let's say they are subtended at the center and then at the circumference, that the angle that is subtended at the center of the circle is greater than the angle subtended at the circumference by 2. Now, this place is trying to tell you that this is the center of the circle, this is the circumference. So the mass subtended at the center is greater than the mass subtended at the circumference, and it is greater by 2. So, for example, if the angle subtended at the circumference is 45 centimeter, then the angle at the center of the circle is going to be 90 degrees. So let's look at two examples in case they give you something like this. They give you a diagram like this, and then you have something like this. No matter how confusing they want, but they will give you something to let you know that this is the circle, this is the center. They will write something like this, O, and then you have A, B, C, and then they ask the question. They say, find. This is how the question comes like. You have A. Let me angle. Find B, O, C, and then they put something like this. Now this thing on a particular alphabet is trying to tell you where the angle is, where the angle lies. So they are just trying to tell you to find for angle BOC. The angle at letter C, but the angle is formed, of course, an angle is formed from 3 points. Now, these are the three vertices of the angle, but this is where the angle lies. So this is BOC, but the angle lies at O. So they ask you to find for this one, and then they give you something like 45 degrees. This is how the question might come like. You have this in your diagram, and they ask you to find BOC. Now, what is that BOC? Remember the rule. The rule says that angle subtend at the circumference is angle subtend at the center is twice the angle at the circumference. So what will you tell them? You tell them that if the angle at the circumference is 45 degrees, let's say we have that if the angle at the circumference is 45 degrees, and then the angle at the equator should be what? 2 times what? 45 degrees, which is going to be, or you can just say angle, you can say BOC is equals to 2 times 45 degrees is equals to 90 degrees. And then they ask you why. You will tell them that angle short. You can write this as your angles or angle. Let's put it a better way. Let's write it. Angles of 10. So 10 at the center is twice the angle at the circumference. The angle at the circumference. Sorry for the abbreviation, let me complete it. Is twice the angle at the circumference. Circumference. Sorry. For those that are you don't need me to tell you what a circumference is. A circumference is simply the perimeter of the circle. A circumference. Circumference is simply the perimeter of the circle, or let's just say the length, the round, moving round the circle. That's the circumference. The wall of the circle is the circumference. Okay, let's go to second theory. Second theory. Let's go to second theory. Second theory. We have the theory of we have this. Angle of the same segment. Angle on the same segment. Now look at this. We have angle of the same segment are equal. Theory number 2 now. Angle of the same segment are equal. Angles on the same segment. They are equal. Now, angles on the same segment are equal. Now, this is a segment. Yes, any line that cuts across, when a line cuts, this is a chord, actually, this is a chord. And this part, go the chord, and then the space. This is a segment. Everything shaded here is a segment. Now, from this segment, from the both extremes of the segment, from the same point, two angles were formed. Two angles were formed. Both angle A and angle B were formed from the same segment. So any angle formed from the same segment are said to be equal. So angles of the same segment are equal. So how can the questions come like equation? Example. You have the example. You have something like this. They can give you a diagram like this, and then you see them give you something like this. A very tricky one. They can give you something like this, and then do like this for you. And then you have information. You can also go and give you this. This is a very tricky one. And then look at what they ask you. They ask you 40 degrees, and then ask you to find for X and Y. So look at how smart the question looks like. This is the center of the circle. So it's a smart question because they are doing two things at the same time. You look at the diagram, they actually asked two questions at the same time. Now remember, this is a segment. These 2 points are the same. But from these 2 points, 3 angles were made. Let me call angle, this the first angle, angle X, angle Y, and angle O. So 3 angles were made from the same segment. And something specifically is happening. One of them was in the center, and the other ones were at the circumference. So how do we get for the value of X and Y? I will first of all find for either X or Y. Let me find for X. Now, remember the equation, the first theory that said angles of 10 at the circumference is twice the angles of 10 at the center. So, for the fact that if angle O, so we have angle O is equals to 40 degrees. Is equals to 40 degrees. And then we'll find out that angle O is 2 times or 2 times, let's say angle, or let's say O, let's use angle O is equals to 2 times angle X. Abi? Because angle subtended at the center of the circle is twice the angle at the, so the angle O is bigger than this man times 2. So if angle O from this equation is now 40 and is equals to 2x, what's now the value of x? Angle x, divide both sides by 2. And then finally we have that angle x is now equals to what? 20 degrees. Now, angle x is equals to 20 degrees because of the first equation. So this man is going to be 20. So angle subtended here is now, angle subtended here is twice this man. So here is 20, here is 40. Because of the first theory. Now, how do I now get for the value of y? The value of y, I will now use the second theory. So, angle on the same segment. Now, you find out that x and y are on the same segment. They are formed from the same segment. Now, remember, actually, this angle, this question, 3 angles were formed from the same segment. But one of them was at the center of the circle. So, it is not. Now, actually, these angles of the same segment are equal when the angles are approaching the circumference. Very, very important point to note. The angles on the same segment are equal when they are approaching the circumference. This man is not equal to them. Why? Because this man is not touching the circumference. If the man had been touching the circumference, then they would be equal. But the fact they are not touching the circumference, they are not equal. That's why this one is kind of more greater than them. So I will now tell them that angle x is equals to angle y. Sorry, angle x is equals to angle y. Why? Angle of the what? Angles of the same segment. Are you seeing it now? Of the same segment. So the angles of the same segment. The angles of the same segment are the same. So therefore, I will tell them that x degree 20. I'm looking for y now. So y degree is also going to be equal to 20 degrees. Since we already got x as 20 degrees. It tells me that circle theory can be tricky. And then they can try to combine one or more theories together and asking you to get. They are trying to know if you are smart enough to decode the theory to solve the question. And once you do that, you are very, very good to go. You are good to run. Now let's look at another theory on this. Now let's look at theory number 3. I would like to use one part of the board so that I will not be confused. I believe you got this. You can pause the video and then get the information. Okay, let's look at theory number 3. Third theory. Let's look at theory number 3. Now, theory number 3, I don't know, the textbook might rearrange it in another aspect for you, or for me, my third theory is telling me that angles of angles subtended by a semicircle is perpendicular. What do I mean? This is a circle, and then we have a semi-line or a diameter, a line that separates the circle into 2. Then they say any angle subtended by a semicircle is what? Is perpendicular. Any angle subtended by a semicircle. But remember that the angle, like I said earlier, must be touching the circumference. Very, very important. Now, these 3 angles, they say they are perpendicular. What does it mean for something to be perpendicular? It means that they are all equal to what? If this is angle A, angle B, and angle C, that angle A is equals to angle B, is equals to angle C, and all of them are all equals to 90. It tells us that no matter how small the circle is, any angle that is subtended inside the semicircle is perpendicular. It's a perpendicular angle. So it's a 90 degree, it's a right angle triangle. 90 degree angle. The angle here is 90 degrees. So let's see the applications. How can we be able to use that in solving? So we have something, I have an example. You have something like this, they give you a circle, and then you have a line like this line. And then they give you something like this. You have something like this. And then you have something like this. Sorry. I'm trying to make something tricky. Because yes, jam will be tricky. Anyhow they come. Just wait for them with wisdom. God will give us wisdom. Amen. Okay, let's see. We have this. We have this boundary like this. We have this boundary like this. Okay, and then you have this is your 0. Okay. Now look at this triangle. Let's look at this on the board. We have angle X, and then we have angle Y. And then we have 30 degrees. Then we now have some here. So we're trying to get smart now. Yeah? And then we have angle Z. But I'm not just trying to give you something, I'm trying to give you something nice that can help you to find out and know the nature of how the question comes like. You can try to scatter your brain, but try at the possible best to maintain your stance when you see the question. Then, poco a poco, little by little, bring out the answer. Now, I look at this triangle. Oh, this circle. Oh, I'm confused. I'm asking to find for 3 unknown, X, Y, and Z. I'm looking for clues. Clues that will give me or get me to my answer. I cannot find for the value of Y, can I? There's no information that will give me help me to find for the value of Y. I cannot find for the value of Z. There's no clue. Can I find for the value of Y? Can I? Yes, I can. Because they told me that here is what? Is 0. 0 means that this line is the center, is bisecting the circle. And if it is bisecting the center of the circle, the angle here must be 90 degrees. Remember, theorem number 3, angles obtained at a semicircle is 90 degrees. So I'll tell them that first of all, y is equals to what? 90 degrees. Y angles subtend in a semicircle. Semicircle. And this commit angles subtend in a semicircle is 90 degrees. So y is 90 degrees. Oh, I've gotten the value of y. What else can I get if I get the value of x? Y. Okay, I've gotten the value of y. Can I get the value of z? No. Can I use that information to get the value of x? Yes, I can. Why? From that, I now find out that y is 90 degrees. Abi, if y is 90 degrees, I now find that from this tip is a shape, and the shape of what I'm seeing here is a what? It's a triangle. Am I right? I'm seeing a triangle, but the triangle is like this. Look at how the triangle looks like. It looks like this. And in the triangle I have here as 90 degrees. I mean, 90 degrees here, here is 30 degrees. Hey, let me clean it so that we will see it very well. So I have something like this. So let's look at the triangle. Here is my 90 degree. Here is what? My 30. And here is my what? My x. Here is 90. Oh yeah, what will be the value of x? What is the sum of the angle in a triangle? Total sum of the angle in a triangle is 180 degrees. I want to tell them that what? X plus 90, Abi, plus 30. That means all the angles here, this plus this is going to give me what? 180 degrees. I will ask myself, if it is why, that's why I'm giving this information, or those that are solving, so that you can be able to know what we are doing. You will tell them angles in a what? In a triangle. The angles in the triangles are equals to 180 degrees. Then in solving, you have x plus 90 plus 30 is 120 is equals to 180. Now what's the value of x? X is equals to 180 minus 120. And then x is equals to 180 minus 120 is 60 degrees. So I've got the value of x as what? At 60 degrees. My y is there. What's the value of y? Y is equals, the value of z. What is z? Z is equals to 60 degrees. Who can tell me why? Let's go back. Theory number 2. Angles of the same segment. We look at this now. you find out that from this same segment, two angles were created, that is x and z. From this same segment, this angle was created, and then this angle was also created. From here, are you see the idea now? So these 2 points created two angles, this man and this man. So therefore, they are the same. So z degree is equals to y degree, to x degree, sorry. So why is it so? Angles of the same segment. Angles of the same segment. Okay, so therefore z degree is equals to what now? Is equals to 60 degrees. Are we good to go? Oh yes, that's theory number 3. Let's look at the fourth theory. You can pause a while and then we go after the question and try to find understanding. Okay, let's look at another theorem. On that, let's look at the theorem of the cyclic quadrilateral. Now, we have a cyclic quadrilateral. What does a cyclic quadrilateral mean? A cyclic quadrilateral means that when you draw a quadrilateral inside a circle, what's a quadrilateral? A quadrilateral is a shape that has 4 sides. Drawing that particular shape inside a circle. Now, what do we assume, or what do we say? It's not an assumption, by the way. It's a theory. Now, in a cyclic quadrilateral, it's a theory we law that the opposite sides of the cyclic quadrilaterals are supplementary. That means the opposite sides are what? Are supplementary. So this is x, this is y, this is z, and this is, let me say, w. So we have w, x, y, and z. So what does it mean? It tells me that w plus x is equals to 180 degrees, and then x plus z is equals to 180 degrees. Now, we said supplementary. Abi, what is the value of a supplementary angle? Is 180 degrees. Get me now. So when they tell you a supplementary angle is an angle that is, I think it is, that is 180 degrees. So they said that the opposite side of the cyclic quadrilateral are supplementary. That means if you add the opposite side of the cyclic quadrilateral, no matter their value, you always get 180 degrees. It's even making sense. If this is 180, of course you have 360 degrees, and the quadrilateral, the total angles in the quadrilateral is 360 degrees. That is the law. That's the theory. That is opposite side of a cyclic quadrilateral is always 360. Is always supplementary. That is 180 degrees. So how can this question? How can this theory? How can you give birth or give rise to questions? How can question come on it? So let's look at the questions on cyclic quadrilateral. So you have something like this. You have something like this, and then you have this semicircle drawn here, and they wrote O here, and inside here, giving you an information that tells you that, sorry, this is a 30 degree. Sorry, this is 30 degree, and then this is is x. The first one no, and then they told us that we should find, okay, this is the first information given to you. And then they came here again. He said, y. Came here again. He said, let's look at the question. Okay. 40 degrees. And then you have z. So we have x, y, and z. This is a question you're asked to find from the 3 angles in this particular diagram. How do we solve this? We'll not waste our time. This is the first theory, sorry. Now, we're going to ascertain understanding it because, like I said, I'll try to combine all the theories all together so that we will not be able to meet. So that if they give you a question, you can just be able to use your mind and then try to combine it as soon as possible. Now look at this diagram. This is a semicircle. Remember I said angle subtended in a semicircle is what? Perpendicular. So this angle is subtended in a semicircle. Therefore, this man here is what? Is 90 degrees. That's the first thing you should be able to code. Now, funny enough, something is happening here. Not just an angle was subtended in a semicircle, but this line is a semicircle. Here is a semicircle, here is also a semicircle. So two angles were also subtended. So this man also, our y is also 90 degrees because this man was subtended by a semicircle, this one is also. So the both of them were subtended by this semicircle. They were formed from the semicircle. So here is 90, here is 90. So first information is that y is equal to what? 90 degrees. You've gotten one of them, that is y. And you tell them y, angle subtended in a semicircle. Okay, now that's the first thing. Now, how do we get to the value of x and z? Oh my god, how do we do that? Now look at this. If you look at this, you sketch out a triangle, you find that there is a triangle here. And the triangle looks nice. It has something like this. We have a shape like this. Here is 90 degrees. And here is 30 degrees. So what's going to be the value of x? So we're trying to be smart now. We will now tell them that what? From this triangle alone, to find for the value of x, we tell them both x plus 90 plus 30, all of them is supposed to give us what? 180 degrees. And why do you say so? You say total angle in what? Total angle in a what? In a triangle. So the total angle in a triangle is 180 degrees. So I'm bringing out this small triangle, and then you find that one side is not given, the other two sides are given. To finish that off, you now have that x plus 90 plus 30 is 120. 120 is equal to 180. What's the value of x? X is equal to 180. 120 crosses over minus 120, and x is equal to 60 degrees. So the value of x is 60 degrees. Then we'll be able to accomplish that. Now, how do we now get for the value of z? I think that's where the third theory will now come to play. How do we do that? Now, we already get the value of x as what? As what? At 60 degrees. And then remember, opposite side of the cyclic quadrilateral are supplementary. That means here is what? Is 69. So this side, all of them as a whole, is going to be what? 100 degrees. I mean, 60 plus 40 is what? 100. So this side is 100 degrees. What of the down? We don't know. Addition of the both of them is supposed to give us 180. So how do we solve it? We now say that what? 100 degrees, that is from the upside, plus what? The man that is down. There are two angles there. Z degree plus what? Plus 30 degrees. All of them are supposed to give us what? 180 degrees. Why? Everything down plus everything up. You're supposed to sum them up together to get a 180 degrees. So because we said opposite side of the cyclic quadrilateral are supplementary, that means that equals to 180. So we say opposite side of, so opposite sides of cyclic quadrilateral, lateral. Okay. Now, how do we finish it? We have 100 plus 30 plus z is equal to 180. Okay? 130 plus z is equal to 180. So your z is equal to 180 minus 130. Finally, our z is equal to 50 degrees. So we are done with this question. It looks bumpy, but we are done. We've done justice to that. So we're able to see that we did three theorems now. From now, we were able to look at angles in a circle, angle in the opposite side of cyclic quadrilateral, and then angles obtained in a semicircle. So I'm trying to mix them so that you will know. They don't just ask you one theory alone. They join them together and they pour it out to you. It's now dependent on you if you are able enough to be able to decode out the theorems you use to get to the answers. Now, because of time, we will run. If it will take series, but we'll be able to complete the theorem today. We have just a few more basic theorems, and then we'll tie knots. See you in the next series if there's a need for that. Comment in the section below if you have understanding or if you have questions. We will see to that. Now, let's look at the fifth theorem. Now, the fifth theorem in the fifth theorem, we're going to see alternate segment theory. Now, what does alternate segment theory state? It says that we have this, look at this line. Now, any line that cuts across a circle is called a dash. That's a question. A dash is a line that cuts across a circle. I'll give you 5 seconds. Okay? Now, what's the answer? Yeah. If you said tangent, then you are right. A tangent is any line that cuts across a circle. Any line that cuts across a circle is called a tangent. Okay, that's by the way. As we continue, now, in this particular alternate segment theory, we have a diagram like this. Now, in the alternate segment theory, please forgive my big address. Just spare that for today. Now, in the alternate segment theory, a line, like I said, a line that bisects a circle is a tangent. Now, this particular line, it is called alternate segment. Alternate segment. That is the name of the theory. It is kind of more. Now, if you look at this particular one is a segment. This particular one is also a segment. And then they are formed from a tangent. Now, this tangent, this is the point of the tangent. Now, from the point of the tangent, 2 different segments were created. And then, according to the theory, the opposite segment created, or when a tangent, 2 opposite segments that are bisected by a tangent, they are alternate. Now, this tangent produces 2 segments, and then for the fact that both these 2 segments are created from the same tangent, these 2 segments are alternate to each other. And when I mean alternate to each other, the angle here is equal to the angle here. And then the angle here is equal to the angle here. Of course, we still remember alternate angles and corresponding angles. Now, this is the alternate segment theory. Now, how can you see question on this? Is that when they give you something like this, they will give you a question. Of course, when you see it, your mind will tell you that, yeah, this is something that you should know. So let's look at this question. They give you something like this. I want to be smart now. And then you bring a little bit down. And here is the center of the circle, and you have a dot there. This will be the next theory. Let's look at this in the next theory. Let's just go with this ordinary segment for now. Now, you have this kind of question, and you have something like this. You have, let's go with this. Sorry for the mistakes that were making, but it's better. You have something like this. You have 50 degree. You have a 50 degree, then you have X here, and then you have 20 degree. Let's not go with that. You have 70 degree. 70 degree here. And then you have, Okay, let's go with x. We have 30 degree, 30 degree. Try to make it look a kind of a little bit complicated. Let's see if we can be able to solve it. Then we have x, this is y. Okay, let's see if we can be able to solve it if I eliminate the 30 given here. So let's try and see if we solve it. We are given this kind of question. Oh my God, I was not given any information here, and they asked you to find consent. How will I be able to solve this one? Let's say they give me the one outside here. Let me give the answer to the one outside. Let me give it, okay, x, let me take it as my y. Let's try. Let's try. Look at this question. You have to find 3 unknowns, 5 information, 2 are known, 3 are unknown. How will I be able to solve this? Oh my God. Now let's go into working. The first thing I'm going to find out is that angle at a point is 180 degrees. So if you have something like this, it's 180 degrees. 180 degrees. So I have three angles at a point. This is a point. 3 angles here now. So y plus 70 degrees plus what? Plus 50 degrees. All of them must give me one value. And that value is what? 180 degrees. Why? Why? You will tell them angle at the point. Angle at the point is 360 degrees, not angle at the point, sorry. Not angle on the straight line, not angle at the point. Angle at the point is 360 degrees. So angle on a straight line. A straight line is 180 degrees. So y plus 70 plus 50 is 180 degrees. Angles on a straight line. On a straight line. Straight line. Okay, now we have angles on a straight line, and then now how do we finish up? We have y 70 plus 50 is 120 is equals to 180 degrees. Now our y is equals to 180 minus 120 is equals to 60 degrees. Our y is equals to 60 degrees. Now the value of y is 60 degrees. I've gotten the value of y as 60 degrees. Now how can I use this information to solve others? Alternate segments. What does it tell me? If here is 60, my z will be what? Are you seeing it now? If here is 60, my z is automatically going to be what? Here is also going to be what? 60. Alternate segment also tells me that if here is 50, my x is going to be 50. So I've gotten the value of what? Both x is equals to 50 degrees, and then my z is equals to 60 degrees. Why is these two things so? We now tell them alternate what? Alternate segment. Segment theory. Very easy. Alternate segment theory. Very easy. Okay, we have 2 more theories and then we time it. 2 more theories and then we will time it. You can pause the video and then go through it again. Okay, let's also look at angles that has to relate to tangent. Angles that has to relate to tangent. Angles that has to relate with tangent. Angles that has to relate to tangent. And then we have tangent that is angles related to tangent. And then we have, let's say, theorem number, I think this should be theorem number 6. I don't know again, you are counting. So let's say theorem number 6. Now, theorem number 6. Let's look at we have a circle, and then this is a tangent. Now, any line drawn from